Right. Good morning, grade 12s. I'm going to try another way. All right. Imagine I gave you g to the x was equal to a third to the power of x. Okay. You need to recognize that this is a decreasing exponential function, i.e., it's going to have that sort of a shape, okay? When x is 0, anything to the power of 0 is 1. If you take any value and you substitute it for x, okay, if I took x was 2, a third to the power of 2 would give me a ninth. So here I can have when x is 2, it's a ninth. If I took negative 2, a third to the power of negative 2 would give me 9. Okay, you can put any coordinates you want on this. Okay, the domain of this graph is x is an element of real numbers. It goes on both sides of the y-axis. The range of this graph is my y is always greater than naught. Okay. If I asked you to write down the inverse of this graph, okay, remember if I'm looking for the inverse of an exponential graph, it becomes the log graph. And all you've got to remember is that whatever the base is drops down to the base. And there is my inverse graph. Okay. If I asked you to sketch that inverse graph, okay, the inverse log graph that is decreasing is going to go like that. Okay. Where the original went through at 0 and 1, this is going to go through at 1 and 0. Where the original went through at -2 and 9, this is going to have the coordinate 9 and -2 on it. This is g to the -1. All right. Okay. For the blue graph, okay, or the log graph, my domain is going to be x must be greater than 0, and my range is going to be y is an element of real numbers. Look at that. Can you see your x is only on the right-hand side? Agreed? Okay, and your range is on both sides. The y is on both sides. If I asked you where g to the x times g to the -1x, let's just say was greater than or equal to 0. I'm asking you, where are both graphs positive or where are both graphs negative? Okay, so where are both graphs positive? Again, the y values. This graph here, my y values are always positive. So I need to know where is my inverse graph always positive. And are you happy that my inverse graph is always positive and it's equal to 0 at that point? Okay. So where do those both overlap? Okay. They overlap when x is smaller than or equal to 1 but greater than 0. Okay. Only here will both graphs at the same time, agreed? The y's will be positive or equal to 0. Where are both graphs negative is not going to work. Agreed? Why? Because my original graph is never smaller than 0. Okay. All right, let's see if I can post this. Okay, good morning, Matrix. I'm going to do last year's control test, question 1, okay? All right. Question 1. All right, so it says, given the arithmetic sequence 3, 7, 11. Okay, so as soon as I've got an arithmetic sequence, I know that my A value is 3, and my common difference I get from going term 2 minus term 1 is term 3 minus term 2, so I get D is equal to 4. The first question says, find the sum to 20 terms. So sum, I go and look on my cheat sheet and I find my sum formula. And my sum formula is sum to 20 is equal to 20 over 2, 2 times A plus 20 minus 1 times D. Okay. And I take my calculator and I go 10 open bracket 6 plus 19 times 4 close bracket, and it will tell me that the sum to 20 terms of this sequence is 820. Number 2, it says if the nth term is 191, i.e. t to the n is 191, determine the value of n. So they're basically saying which term equals 191. So I'm going to go 191, and my term equation is a plus n minus 1 times d. Okay, so I'm going to take 191, I'm going to minus 3 from it, I'm going to divide it by 4, and I get 47 is equal to n minus 1, and therefore n is equal to, damn it, I'm getting dyslexic, is equal to 48. So the 48th term of this sequence is 191. The next question says, determine the largest value of n for which the sum of the above will have a value of less than 120. So the words that stick out to me are they saying sum. Okay? So if I'm looking for s to the n, I don't know what n is. So it's n over 2. I do know that my a value is 3. And I do know that my d value is 4. So if I just simplify this, I get 6 plus 4n minus 4, which gives me n over 2, 2 plus 4n, okay? And I'm going to simplify this because 2 goes into both of those. I'm going to go n 1 plus 2n. And if I simplify that further, I'm going to get 2n squared plus n. So now I've got s to the n is equal to that. But the question wants to know where the sum will have a value of less than 120. So I'm going to say, right, if that's my sum, it must be smaller than 120. So I notice that I have a quadratic equation. Okay? And I'm going to use my quadratic formula. And when I use my quadratic formula, I'm going to get negative b plus or minus b squared minus 4 times a times c all over 2 times a. And if I take my calculator, it's minus 1 plus the square root of 1 minus 4 times 2 times minus 120 all over 4, and that gives me an answer of n is equal to 7,5, or I get n is equal to negative 8. Okay, now if we think of this quadratic equation here, okay, as a parabola, we know that the arms are going up, and basically we've just found out that the critical values or the x-intercepts of this specific graph, which represent where s to the n is smaller than 120. Okay. Now, because we're dealing with a sequence, we're not interested at all, okay? We're not interested in at all in anything on this side, nor at naught, because a sequence only starts from where n is equal to 1. So when n is equal to 1, you're happy we're going to get a negative y value. We're going to get a negative. We're going to get a negative. We're going to get a negative, etc. At this point here, okay, we're basically going to get 120. Okay. at that point here. All right, so we want to know which is the largest value of n so that it will have a sum of less than 120. So it's got to be the one just below 7.5, i.e. when n is equal to 7. If this question was changed around and it said what is the smallest value of n so that 2n squared plus n was greater than 120, okay, then we would look on this side, okay, because it has to be greater than, and we would say when n is equal to 8. Remember, our n values can only be natural numbers, okay? Right.